Okay guys, now we're going to look at inequalities, okay? You will see that there are things that are similar between inequalities and equations. There are some things that are different. For example, the first thing we do with an inequality is set it equal to 0, okay? Then we factor it, just like we did with our equations. We set each factor equal to 0 and solve, just like we've been doing. Here is where it's different. You graph the values on the number line. Then you choose a test value from each section of the graph. You test those test values in the quadratic inequality, or the factored form of the inequality, to find out where it is true. And where it is true is where your solution will be found. So let us look at doing some problems using all of this. And note, when you have it on the number line, it is divided into sections. If you have a quadratic, you're going to have at least 3 sections. If you have a cube on your X, you're going to have 4 sections. So you're going to have sections that you have to check out. And each piece could be a potential solution or not, which is why you have to check all the test values. Okay? And then number 7, which I didn't get written down, when the test value produces a true statement, then that section is part of the solution. If you have 3 pieces, sometimes you'll have 1 piece as a solution, sometimes you'll have 2 pieces as a solution. So it will vary according to what there is. If there's 4 pieces, 2 will be solution and 2 will not be solution. Okay, then 8, graph the solution on the number line first, then write the solution in interval notation. So we have all those things to do with this, which is a lot more than what we had to do with an equation. Okay, when we're doing these though, we have an equation, we have a number line, and then we have an interval notation solution. So it's a lot more going on with these. So let's look at our first problem. X squared minus x minus 12 is less than or equal to 0. Okay? So first of all, let's factor this and keep it in this format for right now. X squared minus x. Well, x squared is going to obviously have x times x, because that's what's going to give you that x squared. Minus 12. That means we're going to have a plus and a minus. Since it's a simple one, I go ahead and put my plus and minus in. And now we need to figure out what it is. 1 times 12, 2 times 6, and 3 times 4. Well, 12 minus 1, because it's my different sign, so it's subtraction. 12 minus 1 is 11. 6 minus 2 is 4, which is not what the number is here is. 4 minus 3 is 1. So 4 and 3 will be our factor pair that we need. Now, which one is positive and which one is negative? Well, the negative sign is in front of my middle term x. Therefore, my larger number, which is 4, has to be minus. Therefore, my 4 goes where my minus is. My 3 goes where my plus is. Less than or equal to 0. Okay? Now, from this point, we're going to drop it to an equation. X plus 3 is equal to 0, and x minus 4 is equal to 0. Minus 3 here gives us x is equal to a negative 3, and plus 4 here is x is equal to 4. What does this mean? It means that on my number line, at negative 3, and at a positive 4, these two numbers are where it is equal. And since I have a less than or equal in my original equation, that tells me these are going to have a solid circle because they are included in the solution. Now, Are we going to have solution on this piece, on the middle piece, or on the right side of it? So let's find out. We will use 0 as one of our test values because it's right there in the middle, a good one to use. Now, we can use a number less than -3. How about a -5? And a number greater than 4, how about a +5? So now we have 3 test values we have to check. We could either use our original equation or our factored form of an equation. And I'll show you the advantages of both ones. If I put -5 in the first, I have -5 squared minus a -5 minus 12. Is that less than or equal to 0? Well, this is a positive 25 plus 5 minus 12. That's 30 minus 12, which is going to make an 18 positive. Is that less than or equal to 0? No, that is not. Therefore, this is false. That section of it is false. Okay? Now I'm going to show you with the second one using the 0. And I like this because 0 plus 3 times 0 minus 4, is this less than or equal to 0? Well, this is 3 times -4, which is a -12, and that is less than or equal to 0. So this is where it is true. Now let's try 5. And I don't care which one you like. If I was in class, I'd ask you, which is your preferred? I'm going to use the second one again. So with 5, I've got 5 plus 3 times 5 minus 4. Is that less than or equal to 0? Well, 5 plus 3 is 8. 8 times 5 minus 4 is 1. That's equal to 8. Is 8 less than or equal to 0? Nope. That is false. Therefore, my solution is right here where it is true, and it's in the middle. And therefore, your interval notation is also going to be used. Remember doing interval notation in inequalities. We're going to do the same thing here. So as we move from left to right, a bracket for our included -3, comma, 4, and a bracket because they're both included. Okay? And there is our interval notation. And I've showed you both ways to do test values with it. Okay, let's go on to another equation. We're going to have to erase each one because we don't have enough room to keep going. Okay? But as you can see, these are more involved than equations are because you have a lot more steps to accomplish it. Also notice, when we put our solutions down, we put them in braces when we had the equalities. But when we're doing inequalities, we use brackets and parentheses for our interval notation. So be careful that you don't get them mixed up. Okay, let's look at this one now. 2x squared plus 5x is less than or equal to 12. Okay, now, is this relating to 0? No. So our first step is to subtract our 12 from both sides. So it does. 2x squared plus 5x minus 12 is less than or equal to 0. Now we're ready to factor. Okay. 2x squared has only one possibility, 2x times x. And now we've got -12. Well, we've got 1 times 12. That's not going to even begin to get to 5. You've got 2 times 6, 10, and no, that one won't be either. And then we've got 3 times 4. And remember, you're going to be looking at a subtraction because of the minus in front of your 12. But I'll wait and put the signs in once I know what it's going to be. 4 cannot go here with the 2 because that would indicate that there is actually a common factor, which there is not. So therefore, 4 cannot go there. It has to go here, and 3 has to go here. So let's look. This is 3 times x. 4 times 2x is 8x. And notice 8 minus 3 is 5. Now 5 is positive. Therefore, my larger number, my 8x, has to be positive, and my 3 has to be negative. And now 8x minus 3x gives you your 5x. Okay, so you see how we factored that. Nice and quick and easy. I know it's going to be harder for you. I do a lot of factoring, so it's easier for me. Equal to 0. Now each one of these, well, less than or equal to 0, we'll keep that. Each one of these is going to have to be put equal to 0 now. 2x minus 3 is equal to 0. X plus 4 is equal to 0. Solve each one of these, and I get 2x is equal to 3. Divide by 2, and x is equal to 3 halves. Subtract my 4, and x is equal to a negative 4. Now I need to put this on the number line. So let's put our number line over here. I have a 3 halves, here's a 0, here's 3 halves, and negative 4. So as you can see, I obviously already have one of my test values in my 0, because that's not part of the solution as such. 3 halves, is it going to be a solid circle or an open circle? Well, less than or equal, it's going to be a solid circle, and so will the negative 4, solid circles. Now, let's find out what's true or not. Let's get something smaller than 4. How about negative 4 being a negative 5? And how about 2 up here, which is larger than 3 halves? 3 test values. So let's check them out. Let's do our first one using this equation here. So let's see. 2 times negative 5 squared plus 5 times negative 5 minus 12, is that less than or equal to 0? Let's check. Negative 5 times negative 5 is 25 times 2 gives me 50. And then 5 times negative 5 is a minus 25 minus 12. Well, this is equal to 25 minus 12 will give me a positive 13. Is that less than or equal to 0? No, it is not. Therefore, this section is false. Now let's look at 0. And let's do it with this one. 2 times 0 minus 3 and 0 plus 4. Is that less than or equal to 0? Well, 2 times 0 is 0. 0 minus 3 is a negative 3. 0 plus 4 is 4. Negative 3 times 4 is negative 12. And that is less than or equal to 0, so that one is true. And now let's do 2. Same thing. 2 times 2 minus 3 times 2 plus 4. Is it less than or equal to 0? Well, this is 4 minus 3 is 1. 2 plus 4 is 6. 1 times 6 is equal to 6, which is not less than or equal to 0. So therefore, this is false. And again, because it's less than, what have you noticed? Both of these were less than. Both of these had our solution here in the middle. What do you think would have happened if it had been greater than? Yeah, then it would have been here and here, because that's where your greater than lies. So you can see that's really important. Okay, let's look at an application problem of these. It says, a box with no top is made from a piece of cardboard. Okay? Whose length measures 6 inches more than the width. So I have a box here. And I have a piece of cardboard that makes a box. And it says the length is equal to 6 inches more than the width. Okay? Now what's going to happen? It says a 2-inch square is cut out of each corner. So we're going to cut a 2-inch square out of each corner. So, what's going to happen on this box? It says if the volume of the box is equal to 110 cubic inches. Okay, so what has happened here? To have cubic inches, remember in volume, it's length times width times height is equal to our 110 cubic inches. So, well, my height is going to be the amount that these cutouts are. Since it's 2 inches and 2 inches, that will be my height, is 2 inches. So my h is equal to 2 inches. But what's happening on the width and the length? Well, if you look at the width, my W is from here to here. But the width of the box, once it's made, is from here to here. So this is 2 inches on each side less than W. So my width is equal to W minus 4. Because here's 2 inches and here's 2 more inches that are going to be taken out of that width. My length, on the other hand, which is 6 plus W, is also 4 inches less. See, 2 inches here and 2 inches here, because the entire cardboard was 6 plus W. So this is minus 4. Let's simplify this to 2 plus W. Now, remember, length times width times height has to equal our 110 inches. So my length is 2 plus W times my height, which is my width, which is W minus 4, times my height, which is 2, is equal to 110 in cubic inches. Okay? Now, I can actually divide by 2 on both sides because this is all multiplication. If I divide by 2, I eliminate my 2's. And I'm left with 2 plus W times W minus 4 is equal to 55. Now, before I can put it equal to 0, this has to be multiplied with your FOIL. So 2 times W is 2W. 2 times negative 4 is minus 8. W times W is plus W squared. And W times negative 4 is minus 4W, equal to 55. Now let's simplify. W squared has to come in front. 2W minus 4W is a minus 2W, and then minus 8 equals 55. Now we are going to subtract 55 from both sides. So it will be equal to 0. So now I have W squared minus 2W minus 63 is equal to 0. 63 is 7 times 9, so we're going to have W and W equal to 0. 1 negative, 1 positive. My 2 is negative, so my 9 has to be negative. and my 7 will be positive because negative 9 times 7 is a negative 63. And negative 9w plus 7w is a negative 2w. So we are factored. Now we have w minus 9 is equal to 0. So w is equal to 9. W plus 7 is equal to 0. Subtract your 7, and I have w is equal to a negative 7. Now, 9 is possible, 7 is not, because you cannot have a measurement that is negative. So negative 7 is not a possible answer. So now let's find what our width and our length is. So this one, my width is equal to 9 minus 4, which is 5 inches. My length is 2 plus 9, which is equal to 11 inches. And we already know that our height is 2 inches. So there are the measurements of our box. Okay, you may have some other word problems in this particular one, but this is the only one that I'm going to do for you. The others, I think, will give you the equation already written out because it will be things like things going up in the air and coming down, and they will actually give you the equation. So you won't have to figure the equation out. Anyhow, so this is your word problems, and this is inequalities with an equality application problem. So have a good time doing your assignment. Good luck!